Hello class 10. In our last class, we came to know about the process that is oxidation reduction, definition, the differences between, and after that the examples of oxidizing agent, reducing agent. Okay. Now today we are going to discuss about the theory of electrolytic dissociation. So we'll go through the main points. An electrolyte on dissolving in water dissociates into free mobile ions, that is cations and anions, and allows the flow of an electric current through it. So what happens when an electrolyte is dissolved in water? It will decompose into ions, positive and negative ions, and they will flow through the electric current. All ions carry an electric charge and are responsible for the flow of current through the solution. The conductivity of the electrolyte depends on the concentration of ions in the solution. So, if the concentration of the ions is less, the flow of electric current will be less. And if the concentration of the ion is high, the conductivity of the electrolyte will be high. The number of positive charge equals the number of negative charge in the solution, and thus the solution is in electrolytic equilibrium. So, whatever number of positive charge is generated, it will be equal to the number of negative charge. In non-electrolytes, such as sugar solution, benzene, etc., there is no ionization and therefore only molecules are present in solution. So in non-electrolytes, where the solution does not conduct electric current, there is no ionization. There is no separation of the ions, positive and negative ions, and only molecules are present in that solution. The degree of dissociation is the extent to which an electrolyte dissociates or breaks off into ions. So the degree of dissociation means it is the extent that how much an electrolyte can dissociate or breaks off into ions. Now we'll discuss about conduction in compounds, how the conduction takes place. The electrovalent compounds consist of aggregate of oppositely charged ions, as we know, positive and negative charge, and they're held in their positions by their strong electrostatic force of attraction. Say for example, in the solid state, an electrovalent compound like sodium chloride cannot conduct electricity despite the presence of ions. So solid sodium chloride does not conduct electricity, whereas if you take its molten or aqueous state, it will conduct electricity. The reason is that in solid sodium chloride, the ions are not free. When the electrovalent compounds are melted or dissolved in water, the force of attraction between their ions are broken and the ions then move about and conduct electricity. Whereas covalent compounds which are polar in nature also ionize in aqueous solution and conduct electricity, like example HCl, ammonia and water, they are electrolytes. Now what will be the characteristics of electrolysis process? Number one, the passage of electricity through an electrolyte causes the positive ions, cations to migrate towards the cathode, and negative ions, anions to the anode, as I explained in the last class in the electrolysis process. So when there is a generation of positive and negative ions, the positive ion will move to the negative electrode, that is cathode, and the negative anion will move to the positive electrode, that is anode. The number of electrons gained by the anode is equal to the number of electrons given by the cathode. So the number of electrons lost or gained will be equal. The product of electrolysis are formed at the anode and cathode itself, since the exchange of electron takes place only at the surface of the electrode. So the exchange of electrons only takes place at the surface of the electrode. That's why the product are also formed at anode and cathode. Only hydrogen gas and metals are liberated at the cathode, and hence are also called electropositive elements. Only non-metals are liberated at the anode and are called electronegative elements. The mass of a substance produced at the electrode during electrolysis is proportional to the quantity of electricity passing through the electrolyte. This comes from Faraday's law. So whatever amount of electricity you pass through it, the amount of substance deposited will be directly proportional. And the process of electrolysis is a redox process. So we know what is a redox process or reaction. The reaction in which oxidation and reduction takes place simultaneously. So electrolysis is that process. So the reaction at the cathode involves reduction of cations, that is gain of electron, as they gains electrons to become neutral, while that at anode involves oxidation of anions as they lose electrons to become neutral. So the decomposition of sodium chloride during electrolysis can be shown like this. NaCl, when you take aqueous solution, when you pass electric current, it will decompose into sodium ion and negative ion, chloride ion. Now at cathode, this sodium ion will go and gain an electron, and it will convert into neutral atom. That is the reduction process, addition of electron or gain of electron. At anode, the chloride ion lose an electron to form chlorine neutral atom, that is oxidation, and 2 chlorine atom can give you to chlorine. Overall reaction will be 2 NaCl giving you 2 Na plus Cl2. Okay, so this is the characteristics of electrolytic process. Next we will discuss about electrolytic dissociation, the process due to which an ionic compound dissociates into ion in the fused state or in aqueous solution. We call it as electrolytic dissociation. Now let us take an example. Solid sodium chloride is an electrovalent compound and its crystal structure contains sodium ion and chloride ions. In solid state, sodium chlorides are not free but are held together by an electrostatic force of attraction. Hence, it does not conduct electricity due to the absence of free ion. So, as I explained earlier, when sodium chloride is dissolved in water, it becomes aqueous solution, or melted, it becomes fused state. It conducts electricity. In the aqueous state, what will happen? The slightly negatively charged oxygen atoms of the polar water molecule exerts a pull on the positively charged sodium ions. A similar pull is exerted by the slightly positive charged hydrogen atom of the water on the negatively charged chloride ions. Thus, the ions become free in solution. So, in aqueous state, the ions become free. So, they conduct electricity. In the molten state also, the high temperatures required to melt the solid weakens the bond between the particles and the ions are also free. So in molten state also the ions are free, so they can conduct electricity. There is a term called ionization. The process by which polar covalent bonds are converted into ions into water solution is called ionization. Okay. Now we have to make a difference between dissociation and ionization. So in case of polar covalent compounds which we convert into ions in water solution is called ionization. For example, hydrogen chloride. When you dissolve in water, it will ionize as H plus and Cl minus. Similarly, water also. Okay. Now the comparison between this, or the differences between ionization and dissociation, this is important. In ionization, formation of positively or negatively charged ions from molecules which are not initially in the ionic state. So in case of ionization, the molecules are not in ionic state. It is in covalent state, we can say. In dissociation, separation of ions which are already present in an ionic compound. Example, polar covalent compounds to ionization. Example, hydrogen chloride, carbonic acid, ammonium hydroxide. Whereas in dissociation, you find electrovalent compounds to dissociation. Example, potassium chloride, lead bromide. Okay. Now, today's assignment. Question number 1. Explain how electrolysis is a redox process. You need to explain it. Okay. So oxidation and reduction reactions, how it is taking place. Question number 2. Explain why solid sodium chloride does not allow electricity to pass through. Question number 3. Define electrolytic dissociation. And the last is write the differences between ionization and dissociation. Complete the assignment and send it in manual.